Cool. So, a pretty exciting week. I bought some more machines. About 2 years ago, on Facebook Marketplace, I found this, they're called Omniturn lathes. So, Omniturn is a company that takes hardened lathes, usually DV59s, and they put CNC attachments on them and then have their own controls and all the logic and everything to make these, basically turning turret lathes into CNC gang lathes. A gang lathe is where you have a block of steel that you have a bunch of tools bolted to. So the tools don't rotate in a turret, they're just all bolted in a line. And then you can select which offset you want to use for which tool. They still make them today, they still do these conversions. They also make entire machines. The GT75, I think is the model, where it's a full Omniturn weldment or casting. I don't know if it's a weldment or a casting. I'm guessing it's a weldment. They basically build a hardened, but format it to be more advantageous for a CNC. Like it's a slant bed lathe, I believe, so the turret's on a slant. So that helps with chip evacuation. Yeah, so a couple years ago, I found one of these machines. It's like pristine. These run on linear guides and ball screws and have servo motors to actuate each axis. There's an X and Z, there's no Y axis. I found this lathe on Facebook. It was like, I wanna say it was about $1,500, maybe $2,000. Beautiful, like even the paint looks good. Very unusual to find one of these machines for that cheap. The catch was it was missing the computer. And I knew this and I bought it because I was excited, and I kind of underestimated the amount of work it would be, especially for me who has no computer skills. I can do email, that's it. I mean, I can do email, I can watch YouTube videos. I'm just gonna text. And I have Andrew who's very good at machine stuff and computers probably. His brother builds computers. I have people around me who build computers, but enlisting people to build me a CNC computer is like, either you have to have a lot of money or you have to have really, really good friends. And I have good friends, but like, that's a lot of work to ask of people for what I would be able to pay them at that time. So that kind of got put on the back burner, and then you can buy a brand new control from Omniturn. It's about $5-6 grand. At the time, that wasn't really a possibility for me. I'm getting closer to where that is a possibility, and then these pop up. The first Omniturn number 1, got put on the back burner, and it's still on the back burner now that I have these ones. On eBay, last week, I was looking, because I have a saved search for Omniturn, just in case a computer comes up, or a cheaper unit that I could make one good one out of 2. Got a notification for Omniturn auction, and it was 2 DV59 Omniturns. Basically identical units, a little different. One has a VFD, one doesn't. So one is manual speed control, which is fine. Starting bid was $1,000 for 2 units. The seller had got them in an auction or something, or with a lot of other machines, and did not want them, so he didn't really care what they went for. So I wanted to buy them. I mean, like, what am I gonna say? A complete Omniturn with a, older control like these ones usually go for $4,000, $5,000, $6,000 depending on the condition. And if I can get 2 of them for the price of 1, it's kind of a no-brainer as long as you have the money available. Actually, something exciting going on here is this summer I'm partnering with Victor Ewan and Drew Morhan, who currently run Antique Brass Exchange. They basically buy and sell trumpets. We're partnering up and we're forming a new business called Beverly Music Company, and it's going to be operating out of the front room right there. They're going to continue to buy and sell trumpets and brass instruments, but just under a different name. And then we're offering furtherance of sales and service for those instruments. So if you're in the Chicago area and you need to come out and try a bunch of trumpets, come on in. Details will be on a new website. I think it's beverlymusicco.com in a couple weeks. So I went to them because they want to make mouthpieces. Before that, I'd kind of been putting off making mouthpieces for people because it's a lot of work to do one-offs. But I kept saying, well, once the Omniturn is working, it's something we could consider. So I went to them and I said, well, let's have Beverly Music buy these machines, so that Beverly Music could make mouthpieces and components, all this stuff that we want to do and we can do and we can sell, but we don't really have the facilities currently to make them in a volume that is economical. We got our money together. They're eBay veterans. Like they're veterans of eBay. They buy stuff on eBay all day, every day. I buy a lot of stuff on eBay, but I really stay away from auctions because they kind of terrify me. So of course I was the one doing the auction. We were on a video call and it's just like I get so stressed out with these things because I remember being in high school, like buying paintball guns for like $50 and getting outbid, and then like it's the end of the world. We ended up getting them. We paid about $3,300 for both machines, which is a screaming deal. Even if they didn't work, it's a screaming deal because they're complete units. You can make them functional. Omniturn still has really good service. I actually was on the phone with them for a couple hours yesterday. Really good service, parts available usually. I actually have an entire extra computer for parts here that I had bought to try to get the first one working, and then it got destroyed in the mail. But we have all the parts. It's very exciting. We got them. And then next day, I messaged the eBay guy, gave him my number. Next day he called me. It's Sunday. We come tomorrow and pick him up, me and my buddies, and he said, yep. I grabbed Andrew and Ian and we hopped on the road. We had a lot of fun. Meredith, look what he's eating.
They're not little bites, they're mini muffins.
Oh, those are the healthy ones, right?
They got blueberries in them. And MSG.
Yeah, those definitely have real blueberries in them. What are we doing today, Andrew?
We're going to U-Haul
Ooh-Haul. Why are we going to Ooh-Haul?
to get a trailer.
For who?
For you.
What did I do?
Bought a couple Omniturn lathes.
That's so dumb. $3,000 for, there's like 3,300 with tax for 2 of them.
I agree, considering a controller would have cost 4 or something like that.
No, a controller is 6. And the plan is still to buy that new control, but now I can actually like make stuff. Yeah, so we're going to U-Haul, and then we're going to get Ian.
Oh man, you know what? This would have timed out if McMaster Car was open on Sundays.
This is Ian's first time moving a machine. Don't judge him too hard. I mean, he only lost a couple fingers, so we're okay. Didn't happen in my shop, so I'm okay. No, it was a whole lot of fun. We drove up to Fox Lake. It's about an hour and a half north of me here.
The rest of the trip is 35 miles, so that's
Wait,
like
how many more minutes till we're there?
42.
42? Oh my god.
I thought it was an hour and a half away.
It's an hour from me. It's an
Oh.
I didn't know we were committing to this. Jesus Christ.
Dude, we thought it was gonna be like way longer.
Jesus Christ.
No, I committed to getting Mexican food on Miles this time. I'm getting 2 margaritas, man.
Ian, what are we doing today?
We're going to Chuck E. Cheese.
I can do that.
If they served pizza in a fab shop, I would work there. I don't even care if it would be like minimum wage. That'd be awesome.
Does everyone keep reassuring me that it was a good deal?
I will tell you it was a good deal if you admit that you like my LeBlanc lathe.
I really don't care about your lathe. I'm gonna be honest. I have a pacemaker. It doesn't work, but I have it.
You
Every
see what
time you bring up your pacemaker, I say go turn it on.
You see what he puts me
Can't
through,
even do
Ian?
that this time.
I mean, your LeBlanc is
See what he
fine,
puts
Andrew.
me through?
I would
Can't
take.
even make the joke about his turned off lathe. Hi, Colin.
Hi, Colin.
Still haven't met you yet, but
The shop we went to was so cool. It was called, I think it was Atlas Screw. His name was Mike. Mike was honestly the coolest guy I've ever met moving a machine. We pull up, he's standing outside his bay door, he says hi, you say hi, and he's just a cool dude. He's just a guy. Like, a lot of times you go and it's like weird old men, you know, have been sitting in front of a Bridgeport their whole life, so they don't really have people skills, but he was a super nice guy. Such a cool shop. They had 30, 40, maybe 50 Brown and Sharp screw machines, and then they had like 20 or 30 Citizen Swiss lathes. A Swiss lathe is kind of the modern equivalent of a screw machine. Screw machines are a bit antiquated, but for the type of parts that this guy was making, low tolerance, Dremel, kind of like when you buy a Dremel bit that's like a stone, he was making like the metal shanks, where it's just like a straight piece of 1/8" steel with a knurl on the end to hold the epoxy stone or whatever. And he was making those for, he said, millions of parts a year. It was amazing. We didn't get that much video inside there because I didn't want to bother him, but we got some video loading, which was pretty cool. Whew.
you said we're going in line with
Yeah, I think so.
Yeah, give it a twist.
All right, come on, Ian.
I think you've moved a few machines in your career, all right?
I have done a couple. Very nice.
Kind of a funny thing, when we showed up, just sitting on one of the machines was an orange floppy disk. Without really thinking about it, I just picked it up and put it in the truck, and I'm very happy I did, because that was the system control disk for one of the Omniturns. And if we did not have that disk, we would not have had a working machine, at least at that point. And it was just like sitting on top of it, and I just like threw it in the bed of the truck. It was literally in the bed of the truck while it's raining, and it's like, it's fine. We get him back, nothing really eventful happened. We got coerced by a meth head to buy some gas at one point, and Ian and I said no, but Andrew said yes, so you know who the nice one is. Sorry. I don't have any cash. Sorry.
Pick
Oh,
up
you
the
should
scrap.
have Andrew now. You know, if you fix potholes, like as a private citizen, you get fined. Look at my machines! Let's try to remember which one's which. I'm gonna get a Sharpie.
Hold on.
Oh wait, hold on. Yeah!
I don't even have to do anything.
That's a thumbnail right there. Hey, it's starting to rain.
Yeah, go for it.
These things I've lifted all week.
Omniturn lathe right here.
Got it.
That hit the computer. And
That would
went
have
right
been bad.
Oh, dude, that would have been so funny.
We're missing all the fun. Look at that.
Oh, come on. Poor young man just ate shit.
Let it not be said that I don't give up on the job.
Let her just be a little bruised. He's all right.
Oh, you guys moved the camera.
You guys, yeah. It was definitely a team effort.
Get a good shot of Omniturn Row taking shape. And we get him back, get him out, and then we start playing with them. And we got three-phase power and single-phase power to one of them, the nicer of the two that has a VFD to set speed control. Something really interesting about these is they take Brown and Sharp 21 collets, which I have seen before. I had a speed lathe that took them, but I did not know it. It was kind of a whole ordeal. Yeah, so it's a dead length collet. It's like a Swiss screw machining collet. I'm very happy that they have them, but I did not really know a lot about them before, so I was a little worried. The main thing I was worried about was capacity, but they can go up to 1.1/16", which is plenty. Most trumpet mouthpieces on the OD are 1.1/16". There's gonna be an op 0 to make trumpet mouthpieces. That's gonna be done on a manual machine, which is basically just turning down most of the diameter to like under 1 inch so that it's just chucking work. It's second operation work on these machines because these machines don't have air chucks or hydraulic chucks. So these are hand lever closers. So these are second op machines. But once my first Omniturn is working, that has a hydraulic closer. So then we're gonna be pulling bar on that first Omniturn. So we could theoretically get rid of that op 0 with that machine, use that as a pulling machine. That way you can make multiple parts without being at the machine. In theory, these don't have parts catchers, so you really don't want to be throwing parts around, so it's likely that you still want to stand at the machine. I don't think we'd want to rig up a parts catcher on these. I just don't think it's worth it. But so these are second op machines essentially, and that's great. I mean, because anything like mouthpieces, rotors are all second op parts. You don't make a rotor in one setup. Probably gonna start with rough blanks, so cored out cylinders. You do the drill holes in them for the knuckles, braze them. So probably the first time a rotor casing sees the CNC lathe is after brazing the knuckles in. Something we do is, is you don't thread casings before you braze the knuckles in, because if you do that, a lot of times you'll burn the threads, and that's why almost all French horn rotor threads, like casing threads, are terrible. So what I did when I was doing mine is you braze the knuckles in, get everything all ready, you get the bottom bearing soldered on, and then you hold the rotor via the bottom bearing OD on the little the bearing stack, and then you thread the casing, core out the taper, and then you leave the bottom bearing long in that bearing dimension, the journal dimension, and then you actually go in there with the boring bar and you set that bearing dimension to the taper of the wall so that you have a perfect rotor. That's not something that a lot of people do, which is why a lot of times you'll have factory rotors that are, concentric's the wrong word, well I guess the bearing journal taper is not concentric to the outside rotor taper, so that they require a lot of lapping, and then one of those is going to be loose. Yeah, it's very exciting. So we got the one power down, and we had, when you buy any machine and when you move any machine, stuff's going to get bumped around. Some wires were out of place, so Andrew went in there, and I think there was a ground fault on the e-stop, so I think he just put a wire in there. It had clearly been messed with over its life. And then we got it working, and we have no idea how to run these things. We have manuals that came with it, thank God. We're kind of just pressing buttons to figure stuff out. It was a lot of fun. And we got it. It only took a couple hours for us to get this thing reading code. Just hand edit stuff, like hand entry stuff, MDI stuff. Make it do something cool.
So interestingly, it won't feed it a taper.
There's no way. I fixed it. I got it re-zeroed. Just takes some time. This thing's kind of slow, but it's going actually pretty good. So we can see here is where I'm typing in my command. Yeah, it's like a CRT. I had to replace this piece of plastic. It's making it really hard to read. Behind it, it's okay. This is the x-axis. That's the y-axis. X is positive going this way, and Z is negative going that way. Since we're at the edge of our home going that way, we can't go Z positive anymore, or else we'll trip out. That's what happened before. So we have to go Z negative. So we're gonna do a little interpolation. So cutting a taper, and then we're gonna go X2, so 2 inches positive, and then Z4. Now we're gonna go Z3. That just scares me. It's too far. So then we're gonna go semicolon, enter, and then cycle start. That's the wrong direction. I didn't go negative. No! Oh, that's so disappointing. Oh, I gotta start again. No! But no, I'll take you around the other machines while that's loading. This is the nicer one of the two. This has a VF variable frequency drive, so we have speed control, programmable speed control. It's a Mitsubishi drive, which is kind of nice. This machine's simpler, no drive, it's fixed speed control that's controlled here. Not a big deal for the kind of stuff we're gonna do. You know, these have manual collet closers, but they do have these spindle encoders, so these can thread. Both of them have it. You got a coolant pump. It's for soluble oil. These that don't do anything. Don't pay attention to those. You know, that one doesn't move, but that one moves. I don't think this is supposed to move. That doesn't seem right. Maybe once the collet's in, it constricts its travel. But I powered this control on. It did not like reading either of the floppies. This one was in it. Yeah, so these run on floppies currently. We're gonna put emulators on them to take USBs. I have one in the garage from the third Omniturn that I bought a couple months ago. Okay, cool, so we're at make jog selection. So we're just gonna hit escape. Select operating mode. We wanna go into manual data input. So we hit M, and then our command is gonna be X2 Z -3. And then we're gonna hit that, and then enter, and cycle start. Yeah! It's going very slow. That's it. I should be able to make that go faster. Let me look at feed rates. So now I can have it go back, so we can go X -2 Z3, and it should go back. Yes. That over-traveled. Why did that over-travel? That's really weird. That over-traveled on both axes. Oh, we're figuring stuff out. No, this one's not over-traveled. It's just the x-axis over-traveled? No, it's sprung back. Servo's on. Homo speed established. Okay, let's go through this again. So here's the first Omniturn I bought. This is not working yet. This is the one that's missing the computer. It is the nicest machine out of all of them. It's the most modern as well. It's really well converted. Brand new ball screws, brand new rails right before we bought it. New spindle. It's just missing the computer. The company upgraded them and then sold off a couple of them and kept the computers for a couple of the extras. They wanted extra computers basically, but they are, for all intents and purposes, the same machines. That has an automatic collet closer, you know, VFD, and it's 5C, which is not sure which one I'm gonna like more. I have a feeling I'm gonna like these Braun and Sharp collets because of the dead length, you know. With the 5C collet, depending on the diameter of your part or the, oh cool, we're jogged already. So that does it quick when you do it right. But depending on the size, diameter of your part, plus or minus like a thousandth, can make a difference on how far the 5C collet actually draws in on the taper, so that you can actually make your parts shorter or longer if the diameters aren't consistent. And with these collets, the way these are set up, there's a locking ring. I should grab one and show you. Don't trip over wires. I don't have a collet yet, but you put a collet in here. It looks like a Swiss lathe collet, and this locking ring goes over it and then pulls. I actually don't know how it works. I'm sure it's fine. You don't have to take this on and off, is my understanding. That would kind of suck if you have to take that on and off. Why would he have a closer though? Yeah, doesn't make sense. Let's learn some feed rates. So these are the G and M codes that this machine uses. So feed rate 7 IPM, G95. So I'm gonna go M and then G95, enter, like start. And that puts us into inches per rev. So then we go, let's try X.1, Z -0.4, F 0.005. That's, I want to go fast. And it doesn't want to chooch. Why can't I go? Okay, I'm gonna turn this off. We'll figure it out. Okay, I got some little line written up. So we're going 4 inches in X, which is this way, and then we're going 3 inches in Z negative, which is towards the spindle. And we're going at a feed rate of 35 inches per minute. I'm just doing it in G94 right now. And we're at the either end of our travels, so we should go enter. And we're gonna go cycle start. I'm gonna keep my hand on the E-stop just in case. Oh, and we messed up. The next day, from that extra computer I actually had a USB emulator in that computer. So I took that emulator out of the junked out Omniturn I have, put it in our new functional one, because it just worked. Like everything on this works. We had to, mess with it until everything got the spindle to turn and everything. It just works. So it was very exciting. So I got that emulator, and last couple days I messed with the emulator because you have to take apart the entire computer, plug it in, and I am not computer savvy at all. So it was very stressful, and it did not work for like a day and a half. And I corresponded with Omniturn over and over, and finally we got it. And yeah, last night I got it, and it was awesome, because you have to you're running it on USB now, so you're running both your programs that you're going to upload on a USB, but also the system control. So with the floppies, there'd be a floppy for programs and a floppy for the system, the DOS stuff. It's all on one USB now, which is awesome. And you just plug that USB in and the thing works. And as long as you don't mess with there's CMOS settings, you have to just make sure that it's reading one floppy, not two, or else you'll get weird errors, which I was getting for like 2 days. I actually successfully converted it to run on USB, which I was like, no way. Like, there's absolutely no way. It's kind of the thing where like while you're starting to do something, you know you shouldn't be doing it, but you're gonna do it anyways because you want to do it, and you're like an impatient child like I am. So we got it running on USBs. I cleaned up the screen. The screen is very burned in, but it's still legible. It was coated in like a 1/16 of grease and oil. Everything in that computer is covered in oil just because this thing was run hard. And someone knocking at the door, I had to go. It was the next day. I moved my desk over here by the Omniturn. So we got it running on USB, which is awesome. I can't believe I actually did it, which is so funny because I hate computers. Got collets for it. I got everything set. It's currently running. So now I have to learn. I know basic G code and M code from working with a friend of mine in Wisconsin. It's actually perfect timing. I started going up there and learning from him 2 months ago, and I just got this guy, so it's worked out pretty good. So I know basic GM code. I can jog the machine around, and I'm learning the Omniturn stuff now. There's a little couple specific things about Omniturns, how they like to read the code and everything. That's different from the Fanuc stuff I've done. I intend to write cam on Fusion 360 and then post that cam to the machine. At least post individual operations and stitch them together at the machine. Like, I'm okay doing that, or on CNC, a G code editor on the computer. That's fine. For some of the really complex parts that we do, like a mouthpiece, I have no interest in hand coding a mouthpiece. That just does not sound fun. So I'm sure it's possible. I'm sure there's people that do it, but it's not what I'm comfortable doing. I know my limits on computer stuff. Fusion 360, I know the CAD side very well. I've done a lot of CAD. The cam side is kind of hard to figure out. So if anyone has any experience with that or anything, then let me know. I could use some help. I'm trying to hire someone on Upwork to teach me, but it's kind of an odd thing to hire someone for. So I'm just gonna keep banging my head against the wall with that, and then we'll get some parts going. I think Andrew's coming tomorrow. We're gonna mess around and try to hand code like something simple like a trumpet receiver, where it's just basically internal taper, external taper, and a counter bore, maybe some trim ring, something like that. So we're gonna try to mess around and code that up, start making those. I think we'll do like a or a bench style, and that's kind of the goal, is to offer more parts, not just for makers but for repair people. There's people are always looking for obsolete, like high-end obsolete instrument parts, and there's only so many Bachs out there, but you can still get new parts for a Bach, and they kind of suck, but they fit. The stuff has been dragged through the mud, and current owners are incompetent. And bench, same thing. New bench parts, if you can even get them to make them for you, they're not going to fit because they're not a bench trumpet. Bench, the stuff that we see on a regular basis, because and especially with Beverly Music coming up, we have started seeing a lot of vintage trumpets, benches, Bachs. Mount Vernon Bach parts are a lot of them are different than new ones, so we're gonna try and capitalize on that with these machines, and hopefully another machine that I just found out today I might be getting from the same guy. So cool. I might end up with a Brown and Sharp screw machine, try to fit it in the basement somewhere, and he offered to come and train me and teach me how to use it for a couple days, which is pretty cool. I went up there to pick up there's enclosures for these that we forgot. Guy's name is Joe. Super cool dude. He has like 50 screw machines and like probably 15 or 20 Swiss lathes, and it's insane. And he's buying out a couple shops, and he's gonna have some machines he doesn't need, and I did not know until I walked in that shop that I wanted a screw machine, and it's so cool. And apparently he's like the guy for screw machine, and he trains people. He flies all over the country to train people to run these things, and he offered to give me a deal on it, which is very nice. And yeah, I might end up with one. They're so cheap. I mean, they go for like $1,000. You can get a screw machine and a bar feeder. It's like, why wouldn't you give it a shot? Especially if the guy who's like the master of it's gonna come teach me how to use them for a couple days. But so basically the plan for that would be the screw machine. You'd be able to get finished parts off it. You can tap stuff, but you're not gonna be able to get like finished rotor caps or stuff like that. But it would be great for like blanking out stuff, like rotor casings. Drilling the hole, turning the OD, cutting a register for the thread, and then you take that, braze the knuckles in, and then you put it on these Omniturns to do the final, internal taper and threading. Trumpet receivers, you blank them out. You can remount them Morse 1 on these machines, drill them, ream them and then turn the OD to diameter, and then you would probably take it on a Morse arbor in the Omniturn. Well, that's kind of sketchy. I mean, you could just like press fit it on a Morse Taper 1 arbor on the Omniturn and then turn the profile and the counterbore for the lead pipe. I mean, that's how I've done it on manual stuff before, but like workflow, getting the thing off the piece kind of sucks. You can do an expanding mandrel. That's what you do, an expanding mandrel with a screw in the end, flares it out, and then holds it concentric. That's what you do. Yeah, the alternative is you don't ream the taper first, you ream the taper second, but I don't like that because those reamers take a lot of force. A lot of times you'll get them to rip out of the collet. I don't like that. I've had that happen way too many times. I have some of the collets. So this is the type of collet these machines take. These are Brown & Sharp 21s. This one is a .380, it's a hardened one. So these are like a screw machine collet, apparently. They're very nice. This is the nice one I have, but I just got one in the mail. It's a 5/8 Brown & Sharp brand. So this is the real deal right here. That's a 5/8. You can see it's not round as it is now, tri-lobe shape, and that's because these have a really large clamping range. So I don't know if you're supposed to use them in that capacity, but they definitely have a large kind of clamping range. So you can see this ring here. This is how you set the diameter of the collet. So you tighten this ring until the lever closes or tightens. Contrary to a 5C unit, 5Cs you push the lever that way to close. That's how you open these. So you actually pull them towards you to close them. And what that does is that pushes a tapered part of the spindle that traverses. There's a little tapered sleeve in the spindle that has the matching taper to this. It actually pushes that sleeve this way, push the collet in that sleeve this way, up against that nut, which makes it a dead length collet, which means that no matter what diameter variation your parts have, say you're making 5/8 parts, but because of your machining skills or just material stock differences, because stock is always plus or minus something. In a 5C collet, if you had different diameters, you would have different pullback dimensions. So the larger diameter your part is, the less the collet's going to move backwards. And even like a thousandth makes a difference. It's kind of amazing. They make dead length 5C collets, which are basically this, but inside a 5C collet kind of shell. But these are pretty sweet. I'm excited about these. They hold really hard. Like 5Cs have good clamping pressure, but these feel like these like chow down. And you could even get serrated ones. I'm sure you can get serrated 5Cs. But so yeah, I'm really excited to use these. If anyone has experience with these machines and wants to come give me a lowdown on how to use them, I mean, I'll figure it out. I'd love some help. I mean, I'm really excited to get these going. We're like chomping at the bit to make some parts. I learned how to touch off tools. I still don't really understand what that tool position means and how you base code off of that. I'm guessing, I mean, that's not true. I understand how you do that, but I don't understand how you get your tool positions into Fusion and like how to do that. So I think you have to like build a machine in Fusion. On the website, it says it has Omniturn stuff, but it doesn't, I can't find them in here. So all I gotta do is some more digging. If anyone has any advice, I'd like to hear it. Well, thanks for watching. Hope you enjoyed watching us move some more junk. If I get that screw machine, that's going in the basement. So the screw machine itself should be no big deal, but it has a 12-foot bar feeder. So if you want to watch us get a 12-foot bar feeder down a 4-foot hole, maybe you should subscribe.